Alors, nous avons le plaisir de recevoir donc Kurt Garloff de OSB Alliance, qui va nous parler donc de projet de cloud souverain et donc de sa construction et de la stack qu'ils ont utilisée pour ce projet. Kurt, the floor is yours.
Merci beaucoup. Je vais donner la conférence en anglais parce que si je le fais en français, mon français n'est pas assez bon pour ça. Welcome. Thanks for joining the session. I'll talk a bit about Sovereign Cloud Stack. That's a project I've had the pleasure, the privilege to lead for the last 4 years. Felix, unfortunately, is not with us. He wanted to give this together with me, but he couldn't come. I'll quickly introduce myself. I've been doing open source all of my professional life, actually. So I've have an education in physics, but never actually got to use that a lot in my professional life. And doing open source was always fun for me. Did some Linux kernel work, and then since 13 years now working on clouds. Maybe the largest one that I was responsible for is the Open Telekom Cloud, which is a large OpenStack-based cloud from Deutsche Telekom T-Systems. Looking at the state of affairs, I mean, being an open source person, loving open source, I actually look at the state of open source, and I could be actually really happy because we've been successful getting a lot of the infrastructure running on open source. I mean, basically almost all of the things you use every day run on open source, appliances, TVs, smartphones, all of that. So, and also open source has become the standard way for companies to collaborate across company borders, or sometimes within the company across department borders, then they call it inner source. So very successful, and we've been witnessing this incredible speed of innovation thanks to the fact that with open source you can just really look at the work of others and then base your own work on top of that, and you don't have to like reinvent things again and again, which is still the norm in the proprietary world. So things are fine, except maybe that we have these platform businesses today. And actually, if you look at those platforms, there's a huge amount of open source that's in there. They are using a lot of open source. And still, it doesn't give you, as the user of those platforms, all the privileges that you have come to expect from open source, because you cannot just use those platforms and then decide, okay, I want to have more control, I want to run it myself, or want to change some of the parameters, because those platforms are run by somebody else and they are not 100% open source. So the fact that they are using a lot of open source doesn't really help you that much to have more freedom, to have more control over your data, over your infrastructure, over your ability to innovate. We want to change that. So we can do better. We have actually, looking at what the open source community has built, all the pieces we need to compete with the likes of Amazon. I mean, the fact they are using so much open source kind of validates that. But of course, we then need to still put all those technologies together into something that's a coherent, easy to operate, easy to use stack. And that's something we have not done yet successfully. Open source has this huge advantage. It gives you all those possibilities. You can build the things exactly the way you want. But also sometimes the disadvantage is that everybody does it on their own way, just being slightly different from how everybody else does it, just being slightly incompatible, and this way not being successful creating one platform that is perceived as something that's one platform. That's really then also putting a challenge for those people that want to build and operate it, because they also then have to rebuild the similar knowledge again and again. They have to also find the good engineers that are able to operate complex infrastructure. So we wanted to change that. This is basically our the reason for us to be in the business. We want to build one platform that's standardized and built and operated by many. So let's get those open source projects together. Let's agree on some best practices, how we build a common stack together. Let's put some standards around that, so users that use those stacks from different operators still have the feeling that's the same platform, and they can easily move from one operator to another, or maybe better, use a number of them together. So with that idea, we actually were looking if that is something that resonates with the industry, that resonates also with politics, because of course one of the things we do observe is that within Europe we are unfortunately very dependent on US technology if it comes to infrastructure. So I mean all those cloud platforms are either American or Chinese, which is not possibly the best way for us to be able to create value in the value creation chain. So we went with that idea, had a couple of discussions, and to our surprise, very positive surprise, we found a lot of support from politics, from the German government. So we talked to the Sprint, that's the Agency for Disruptive Innovation, and they were extremely supportive and also able to quickly say, well, okay, this is something that we believe is needed. And we were rather fast to be granted a paid research contract. So we could actually do some, okay, let's investigate whether this can be done, whether this can be successful. And then with that, obviously a small project, I mean, they do not grant you large money quickly. We actually had the time and the ability to create a large funding proposal that went to the BMWK, that's the German Ministry for Economy or Economic Affairs and Climate Action. And they also were very supportive because they say, well, this is something our industry does need. It's also something actually our public administration needs. But they have slow processes. They're also running lots of projects. Advantage, if you get some funding there, it's a larger project than the small things that the disruptive agency can do. So, yeah, that's what we did. We wrote like this 100-page proposal, plus lots of tables with numbers, and proposed to do that project. And 2020, end of 2020, this was basically finalized, handed in. And we had worked with the ministry already in the preparation. So half a year later, actually, we received funding, multi-million euro funding, which is really nice because this allowed us to build a team and then also pay companies to do development work for us. So here's what we built. Standards. I'll explain in a second why that is important. But I mean, building an ecosystem only works if the customers have some common things to build on, if things look the same. So talking about fragmentation before, this is how we overcome fragmentation. And then once you have standards that allow users of such a cloud platform to move between platforms or to use several of them as one, you of course also need to make sure, okay, there is open source software that can be used to implement those standards. So we had a lot of software development in the project. And then third of all, and I think that is something that's sometimes overlooked by people, installing and successfully getting to work such infrastructure for cloud and containers is something that is not easy, but I think a lot of people have done it successfully. Then running it in production successfully with high reliability, with all the things that do happen in production, like evil guys trying to attack you, bugs that need to be fixed, hardware that has outages, is obviously also a challenge. And that's actually, I think, a larger challenge than actually getting it to work. And one of the things we've done successfully with open source is we have created ways to collaborate, to build software together. But what we have not done yet as much is really create common knowledge how you do operations. So that's something we wanted to do with the operational knowledge, a pillar in our project. Important to understand why we're doing what we're doing is our understanding of digital sovereignty. We heard this morning that people started to hate this word, and to be honest, I started to hate it as well because I almost call, well, I'm always tempted to use the term sovereign washing when I hear people talking about sovereignty, because this has become a marketing term now, and we have these sovereign, so-called sovereign clouds, now, where you have proprietary technology run by a proprietary company, not sharing any transparency, and then the fact that it's hosted in your country and then there are some controls for not sharing the data makes them call it sovereign. That is not what we believe is sovereign. Maybe, if they do everything right, they can deliver on data sovereignty. Maybe they can fulfill the data protection rules, the GDPR rules that are in place, if they do everything right. They will not give you the ability to choose between providers. They will not give you the ability to actually inspect the technology, change it, adapt it to your needs, improve it, have innovation at that level. That's what we call maybe technical sovereignty. And you need open source in order to be able to do that. Or sometimes we go actually a step further and talk about the 4 opens. It's not just the code license, but also the fact that the code is openly developed, that the design is open, your community is open, so you can actually meaningfully participate and contribute. And then the last one I just mentioned is what the open operations is about. You have transparency into how this stack is operated, how it's working. So you could actually, if you're sufficiently large, build a team of maybe half a dozen people that runs the infrastructure for you yourself. And actually that's something for large companies can make a lot of sense. You can save some money, for example, doing that, or if you have like special requirements, that's something that may be beneficial for you. That's what I just explained, the different levels of digital sovereignty, how we look at it. And we also decided that, okay, for the solutions that our partners build based on the technology we do, we will make sure they can prove to their users, customers, whether they actually fulfill those sovereignty criteria. So we have, for the technical interoperability, compatibility features, we have this SCS compatible level that really basically guarantees the customer, okay, if you're building your software on this cloud, on this container infrastructure, and you want to move from one operator to another one, or maybe use them together, that is possible because we have this technical compatibility guarantees in place. And this is something where we are obviously building on top of conformity tests that exist upstream from the CNCF, from the Open Infra Foundation, and then a few of our own as well. And those are also automatically tested on a nightly basis, and you can test them as a user, but we also do it for the user and actually display the results publicly. So I will show the compliance monitor in a second. And then obviously for the open source part that allows you to have technological transparency, we have the SCS Open certification, and for the fact that you have like transparency and knowledge about operation aspects available and you contribute to that knowledge base on open operations is something where we have the SCS Sovereign logo. Quickly talking about standards, so this is our documentation page. There's a list of standards that you can see. We follow the RFC way of doing standards, so using the same language. The process, how we basically go about standards is also documented. If you're a developer, those will be GitHub workflows where you make proposals, they will be discussed. If there's enough support, they will be merged as draft. And then if there's support from the team that's responsible, they will be stabilized and become effective, and then they can be pulled into the standards. This is the compliance monitor I just talked about. So this is a screenshot from this morning, where you can see the most of those are public clouds. There's also like 2 private environments there that we also test. You can see basically which of the clouds exist there and which of the standard tests they succeed. And you can see that we have, for example, I'll skip the first one, a test environment. For example, Plus Server is the oldest partner of ours. They have meanwhile 4 regions, and they passed the version 4, the version 5 of our infrastructure standards, which is really nice. We also have a few providers that only pass version 4, so they have to do a few adjustments to also be compatible with version 5. And we have, for example, Sys 11 They have pre-existing infrastructure which they configured to be compliant, and they haven't found the time yet to move from version 3 to the newer standards, unfortunately. But it's something we are in discussion with them, so they will fix that soon. Maybe one additional detail on this table. In the last column, you can see something that is called HealthMon. We have a health monitor running against all of those environments, which basically, with user privileges, all the time builds virtual resources, virtual networks, virtual storage, virtual machines, tests whether they work well, and once they do it, they are cleaned up again, and then it restarts, and then we record the performance metrics of that, which is good for example for capacity monitoring, but most importantly we record whether they succeed or not, and if they're not succeeding you can see that in a dashboard. Users can actually see that, that's also public information. Well, what this does allow us is to build this vision that there's many clouds, and because they do adhere to the same standards for users, it looks like one large virtual platform with several providers that are contributing to that. And this can be public clouds, it can also be private clouds, government clouds. Quickly talking about the software that we're building. This is a rather traditional way of building a cloud and container stack. We have like standard server hardware at the bottom. We do virtualization for compute, storage, network, using the technologies you would expect, Linux, KVM. For storage, we're using Ceph, and also for network, we're using the OVN technology. And then on top of that, we have the core services from OpenStack that expose a consistent API, so you can manage those virtual resources according to standard APIs. And then importantly, on top of that, the container platform where you have Kubernetes as a service, so we really build those clusters on demand for customers as they want that. We're using the cluster API technology for that, which you can see from the multiple turtle logo there. Important, in order to be able to operate this in a good way, you need to have the tooling available to do the lifecycle management, to do the metering, logging, all the automation tooling, basically the operation tooling you need. So they are part of the software deliverable that we have. You can, of course, this is modular, you can, of course, exchange them if you like, but we have a complete reference implementation that delivers all of those. And then also at the right-hand side, you see the identity and access management solution, which allows you to do, for example, user federation between different clouds. I'll skip that. Well, I'll just say maybe one word. So when I mentioned that we had some money to do development work, this is of course public money. We do public tenders, and if you have similar situation, maybe there's one learning I want to share with you. Doing public tenders is a huge amount of work. Doing it in a way that you're not legally in any trouble. And we had like 15 or so of them, and we should have done larger tenders with and less of them. It would have saved us a lot of work. Skip that. Maybe just mention we're working, of course, very closely with the upstream communities, contributing to Kubernetes, contributing to OpenStack, contributing to Cluster API. Talking about knowledge, so that was like the third pillar, making sure there's operational knowledge available. So this is our documentation page, which really is basically the entry point to a lot of useful information that you can get. We've also started to work on one initiative which we call the Open Operations Initiative. Actually found a couple of companies that liked the idea to say, well, like we collaborate on open source development, let's also collaborate on building knowledge on the operational aspects, operational challenges that exist. And this is something which actually goes beyond our community. So we have some people that build completely different open source software that also like this and contribute that. We have like a meetup once a month where we meet and discuss concrete examples. Adoption, so this are some pictures from our summit. We had like more than 200 people in Berlin this year. It was the second summit already. And this is the list of companies that are working with us on this. There's 5 public cloud provider, 1 community cloud provider on there, some more upcoming, and then of course technology partners that build technology with us, integration partners that have like consulting and implementation skills. One good example, obviously, for a workload that works well on sovereign cloud stack is the Open Desk project that you may have heard about this morning. So we have done that work that works just nicely. Talking quickly about the future, one important thing that's happening currently is we've worked with the GovStack initiative. This is a initiative that defines digital infrastructure building blocks for the countries in the world. So it's a United Nations initiative. And they have actually, we've worked with them and they have actually created a specification with standards that fit very well with what Sovereign Cloud Stack wants to do because they have the same vision of digital sovereignty that we have. So we expect there to be a lot of activities. We're working with some countries in Africa now to build clouds there. And we're also working with the UNICC. Looking into the future, our project is end. So this was like a funded project. We have kind of split the responsibility between building the reference implementation and building the standards into two different things because standards need to be vendor neutral. We don't want to have like commercial interests in there. So that continues to live with the OSBA, which is a non-profit organization. And then we have those technology companies that build software and live from support, maintenance, and integration work. We've recently made this announcement that we have now 14 companies that are willing to pay some money to the OSBA for running what we call the Forum SCS standards. That's where the standards will live on, and those are the logos of the companies that are contributing, and we are very grateful to have them, so we can continue that work. I'll stop here so we can have some questions.
Thank you, Kurt. Any question? Don't be shy. En français ou en anglais, on peut traduire après si besoin.
Vous allez traduire?
Ah oui. I have a question. You mentioned the fact that there is maybe 5 different cloud, public cloud providers that are in this project. How do you deal with the sovereignty in general with this public cloud that are more general? Is it compatible or there is no conflict here?
So, I mean, if you stay within the SCS world, those cloud providers are fully compatible to each other. So you can change between them without any technical hurdles. Obviously, if you want to change from SCS to Amazon or the other way, I don't know why you would go from SCS to Amazon, but maybe the other way, obviously there are technical differences that you need to work through. I'm not sure I was answering your question, sorry.
Well, in fact, it was more in terms of, developing the standards with some public cloud actors that have maybe different interests. How you deal with that?
Okay, that's an interesting one. So, I mean, every commercial company has this natural tendency to be willing to lock in customers. I mean, they want to provide something that makes it hard for the customers to go away. And that's something we actually had to overcome because the whole value proposition of having SCS-based offerings is to go to a customer and say, well, I don't want to lock you in. I want you to stay with me because I deliver good service to you. And actually, that is what people that have been experiencing this login with VMware, for example, that's what they are looking for. They don't want to ever be in the same situation again to have such a dependency on a provider. So we've actually had the CEO of our largest partner, PlusServer, on stage basically saying, well, I don't want to lock you in customers. There's no data out transfer fees. And we really make a point of staying fully compatible with all the other SCS people. So you stay with us because we deserve it, not because we make it hard for you to change. And that's actually been resonating with their customers. That's why you wouldn't have said that on stage otherwise.
Okay, thank you. Je vais pas faire toutes les questions quand même, si.
Do you have maybe worked with the ENISA to work on EUCS or these types of future standards and how SCES could integrate with that?
Yeah, so I mean, we're obviously aware of the EUCS standards and the data protection things they care about. This is mostly work that our provider partners need to do. So what we try to do is we're trying to learn, okay, what are the requirements? What can we build into the architecture to make it secure? So there's some security certifications that our partners have gone through. So we basically try to make it easy for them to pass that, but we cannot do it for them.
The non-lock-in is something that's very interesting and is, of course, something that's present in EUCS, for example. So that's a quick win if you... Yeah, but okay. Thanks a lot.
Well, thank you. Merci beaucoup.